person from the community came to me with a simple question. I really like this kind of setup from Dune. Is it possible using just regular rocks to create something like this? And after speaking with them for a bit, it seems like you mostly was looking for like the stacking rock setup that it kind of looks like here. But to be clear here, that's not just what this is. This is very much handcrafted. It's just being reused, and you can tell it's being reused and handcrafted because if you take a look right here at this area, that's this right here, right? This part you could tell is this, right? It's the same setup here, just rotated. So in this actual game, people have went in and handcrafted and art directed specific setups and just spread them out. So there's a few of them and they're probably scattered around, but this being the PCG kind of tutorial channel, I guess, I'm not going to tell you just, oh yeah, go ahead and just make that and have fun. Instead, I'm going to show you how to do it somewhat procedurally. Obviously, the final look is not the same. We're going to get something along these lines instead, where we have these kind of stacking rocks, and you can see it is inspired by it, but it is not actually the full like same system. The nice thing is you have a lot of control for these. You can specify what kind of shapes you want. You can specify how tall you want them and things of that nature. So there are some positives to doing it this way. If you wanted to actually recreate it though, you would need to, of course, do it all from scratch. All of these though are done with just 3 rocks. 3 rocks and a world aligned texture. So there is some benefit to it. So with that out of the way, let me show you how it's set up. To get started, as always, make sure you go to Edit Plugins, search for PCG, and make sure your procedural content generation framework is enabled. And if not, go ahead and turn it on and restart your engine as needed. Before I actually create the PCG graph, I want to get the rock formations kind of set up. And we're going to do that through level instances that are then going to be converted to PCG information. What I'm going to do is I'm just going to come here and I'm going to drag a rock out here. And then not worrying about kind of the position of it, the rotation or anything, I'm going to start duplicating around to figure out roughly what distance do I want pieces to be next to each other for, and roughly what shape do I want. So for example, if I want something that is more of a straight line, maybe I can do something like this. If I want it to be more of maybe have a little indent, we can do something along these notes. Don't worry about the fact that it is not going to be the prettiest. This is all just going to be one of several kind of preset setups that we're going to be used and then modified from there. The main thing about these rocks though that I'm using, whether it's this one or this other one or this last one, is they're all roughly the same size. Them being roughly the same size makes this considerably easier, and you can always scale them up or down later on in PCG anyways. And we'll be randomizing it a bit too. So let's say this is kind of the shape that I want. Well, all I need to do is go ahead and select all of these pieces. There they are all selected. Then I'm going to right click, go to level, and create a level instance. I'm going to uncheck external actors, and I'm going to set the pivot point to center. The other key thing here though is make sure that the pivot point of every rock is also in the center of the rock. So that way when it rotates, right, it doesn't rotate from an odd pivot effectively. You want it right in the center, in which case this center is good because it's going to be vertically the center because we didn't move them up or down. And we're just going to get the horizontal center basically. Hit OK. And now I'll go ahead and save this. I already have 2 of them created. I'll go ahead and save this as rock group C so you can see how it's set up. And when you have that in there, you no longer need this guy. You can delete it. And if I just drag in rock group A, rock group B, and rock group C, you'll see that there you go. There's our 3. You can see this one, I use a different rock. It does not matter for this kind of setup. All we need to do now is here in rock group C level, right click, go to asset actions, and all the way at the bottom, create PCG assets from levels. Hit OK. And I'll just save it as the default name. It'll go ahead and create a PCG data asset here with the original name _PCG. And that's good enough for me. Just a quick note though, if you ever modify this level instance anyway, it will not automatically generate this. So when you do modify it, just make sure to right click again, go to asset actions and recreate it. It'll overwrite it and that will update it. They're not automatically linked. But now that we have kind of our rock formations, we can go ahead and get this set up with a PCG graph to actually spawn everything. Now you also might be wondering why I'm setting up these rock formations. It is not required. You could procedurally spawn your own rock formations with PCG. Here, I'm just giving it a little more art direction version compared to just whatever it's going to have with the logic of PCG. Some parts are easier to just art direct a little bit. Some parts are easier to just go full procedural on. I like this kind of mix for this setup. Plus, this way I can show you how to use multiple PCG data assets and randomly spawn them on every single point. So hopefully that'll be helpful for some of you guys. But with that out of the way, let's go ahead and create our actual PCG graph. Go ahead and right click, go to PCG Graph. We'll make an empty graph here. I'll call it something like PCG_rock pillars. I'll drag it out into the editor here, and where it goes does not matter. All we're gonna do is now open it up. And now here we can get started with a few things. Starting here in the bottom left with the graph parameters. I'm gonna want at least two things here exposed. I'm gonna want the actual data assets as a parameter, and I'm also going to want to have the material that I'm going to be overwriting things with. You can also have the meshes exposed. You can specify which rocks you want to spawn or not, and of course a ton of other stuff. I'm just going to show you a few, and then you can use the same process for all the other parts. So let's make a new parameter here. I'll hit the capsule here, and we'll change this type to a PCG data asset. So right here, we want an object reference. And then I click the drop down here, and then change the capsule here to be an array. And then click on new property, hit F2 to rename, and I'll just rename it to PCG data assets. So now I can go ahead and add 3 entries here. And if I just click the drop down, you'll see there's our 3, because those are the only ones I have in the project. So you go ahead and select one of the 3 here. Okay, so we have this one, and I just need the material. So click add a new property one more time, select the capsule, and this time I'm going to grab a material interface and material interface object reference. A material interface is something that will take both a material and a material instance. So if you want to only be able to take material instances, you can just set the type to material instance. If you want to do just like the main material, you could do that as well. The interface one allows for both, which is awesome because I don't really care which one you plug in. So one more time, I'll click on new property, press F2 to rename. I'll call it material, and then I'll plug in my material in here. The material I'm using is extremely basic. It is just a bunch of world aligned textures, and I've done a little bit of color correction on the base color here. And that's how we kind of get this look. Absolutely nothing fancy here, as this is primarily for the demonstration tutorial. But if you wanted to, you could apply displacement to this as well and go even further, or a bunch of more controls, etc. The main thing is we got our material and we've plugged everything in. Okay, so now let's go ahead and get started. So the first thing I want to do is grab ourselves some points to actually work with. So right click and do a create points grid. And this part here can be wherever you want to spawn them. It doesn't have to be the create points grid. This again for the demonstration. If you have already preset locations, you can just use them. In my case, I'll go ahead and set some of those points up myself. So in my case, I'm going to use the create points grid with 3000 by 3000 grid extents. And let's say the cell size will be 1000 by 1000. So they're kind of spaced out. I don't care about the verticality, so we'll keep it as is. The coordinate space, though, I need to change from global to local component. So that way it moves with the volume, and then we're good. But this is going to be way too many points. So immediately I'll do a select points node, and I'll go ahead and keep the ratio at like 0.2. So if I press D now to debug, you'll see, there we go. There's the point. So in this case, there's 4 of them. If I go ahead and move the volume, right, we get a few more, and we can play around with how many we want and kind of where they all appear. This is just fine. I don't need super many of them. But one thing I definitely don't want is for all of them to be so grid-like. I want them to be a little more varied and rotated. So we'll just add a transform points node, and using the transform points, we can say, okay, rotate them 0 to 360 degrees along the Z, and go ahead and scale them between 0.75 and let's say 1.5. So it'll rotate, it'll scale, and let's actually offset as well. Let's do minus 300 in X and Y to 300 X and Y. We don't want to be moving it up or down though. So now if we take a look, there we go. That's a little bit more interesting, right? And we get a little bit of variation here. Fantastic. So now let's assign basically the random level instance or the PCG data asset to each of these points. Now there's a couple of ways of doing that. One of them is to just do an add attribute node, the parameter version here. And then we can just go ahead and grab the PCG data assets, drag it in, and plug that in. When we do that, if I press A on this add attribute node, you'll see there's all our points. And if I scroll all to the right and go ahead and expand this none here, because we haven't given it a name, you'll see that's ABC, ABC. It is exactly in order. So if you're looking for an even distribution of all your stuff, this can do it. And you're already spawning them in random locations, so this might be just fine. you can assign a fully random setup. And for that, instead of add attribute, we'll use a match and set attributes. So when we do this one and then we plug in the assets in here, and I press A to take a look at them. And again, here all the way on the right, we have PCG data assets. We'll go ahead and open it up a little bit. We can see here ACB, ACB. If we had a little bit more, so if I just go ahead and turn the ratio just to 1, so we can see a bunch of them. You can see here CCAAA, CCABC, right? It's now randomized. Each one got a random one. I'll go ahead and put the ratio back down. So we have, in this case, fully random. We can change the seed. And when we change the seed here, BAA, BAA, not a single C1, right? It's entirely seed-based. So while I got all three, you're not guaranteed. So it's up to you really how you want to do it. Since we're throwing them everywhere, you're not going to notice either way. But if you were using weights, then match and set attributes would be the way to go. For me though, this is just fine. All I want is to assign a random one to each of the points, so great. Now I can go ahead and loop on every single one of them because I want to read the data. To loop on them, I need to drag out and do an attribute partition and do a simple attribute partition. So instead of last, I'm just going to specify just to be sure. And I want to specifically say I want to loop on this. Now, it's a long name. I'm going to right click, copy attribute name, and then I can go back to the attribute partition, open it up, and just go ahead and paste it in. At last will work just fine because that is the last one being used. But if you had multiple attributes being piped in, this just guarantees that that is the specific attribute that we're using here. No guessing. Plus, then you can actually read it right here. So at a glance, you can understand, okay, we're partitioning by this versus trying to remember what you had here. So now we need a loop. We need to loop on all of these based on however many we have here. So for that, let's go ahead and make a new PCG graph. We'll right click, go to PCG, PCG graph, empty graph. I'll call it PCG loop underscore assign PCG data assets. The name is not super important. But then we can just go ahead and grab it and drag it out into the graph here and select the bottom option to create a loop node. And then within being in here, we can just double click it to open it. For the input here on the pins, all I've done is change the input here to be of a usage loop, allowed type points, and the pin status to be required. And then the output, I just changed the allowed types to be point and the pin status to be normal. It's a very simple setup here. All we're going to do is grab the information from the input, which are our points, and copy them as needed. So from here, we can just drag out of the input and do a get attribute from point index. The attribute that we're getting is the actual variable that we were setting. So I'll go ahead and paste it in here as well. So we're grabbing this input source PCG data assets. The reason we're doing that is because we need to know what that information is for all of these points. And despite us getting the index 0 here, it doesn't matter because we've now partitioned it that all of the ones that are the same are together. Everyone that was assigned this one on index 0 is here all together. So whether you're getting now element 1, 2, 3, 4, 5, it doesn't matter. But now that we have that, we can just use the load PCG data asset node, open it up, and you'll see that we have a spatial data out. Now, if I just plug this into asset, you'll see we still have a spatial data. But if on this load PCG data assets, we go ahead and assign an asset here, let's say group A here, you'll see it goes to root and points. And now if we go ahead and select this attribute and plug it into asset, it still maintains roots and points, and that's where we're going to be using. Because I want to know where all the points are, so we'll go ahead and grab those. And I want to copy the points from the data asset that we have. We're going to copy them to the input points. So at the locations of all of the ones that were there originally. And then I just want to output all of those points, just like so. So nice simple setup here. And now in here, we can go ahead and just drag it all the way through and plug our out into the in of the loop. If I just go ahead and debug them by pressing D here, you'll see, hey, there's our little rocks, or rather the points for them, right? In those locations, we now have the different setups. So you can see here's the one we just created and a couple of the other ones we had. And if I go ahead and randomize it, right, we get the different setups. Some of them will go ahead and overlap. And I do not mind that one bit. So we have some effectively that are going to be smaller, bigger, more interesting, a little more simple. I personally really like that. So we'll go ahead and go with this. Now, after copying the points are exactly where we had them relative to each other. So I want to move them just a little bit around compared to where I originally placed them. Maybe a little bit to the left, a little bit to the right, so it's not perfectly the same spacing as I actually drew. So for that, all we're going to be doing is using a simple transform points node. And I'm going to say, okay, you know what? Let's move it minus 100 to 100 in X and Y just to give it a little bit of variation. So if we take a look here, this is no variation. And if I go ahead and enable it, this is some variation, right? So you can see it goes ahead and just slightly varies it, which means we sometimes will now get a gap. Sometimes they'll move a little bit closer, right? It's just a little more interesting despite using the same kind of setup. And you can, of course, modify this transfer points to be whatever you like, give it more variation, change the scale, etc. For now, though, this is fine. The next thing we want to do is basically take all of these points and duplicate them up randomly. So first we want to assign a random number, basically, of duplications. How far do we want them to stack? Then partition by those, and then go ahead and actually duplicate them. But one thing I want to do is when I do the random value, I want to kind of force more numbers to be lower than higher. So primarily, we'll have smaller stacks, but occasionally we can get a higher one, of course. And this is just so they're not always equally all tall. I feel like occasionally seeing a taller one is nicer. Of course, set it up however you'd like it for your setup. And the way we're going to be doing this kind of more forcing it to be lower numbers is by basically using a power node to tweak the values. Let me show you. We'll start by using an attribute noise. By default, throws an error because we haven't set it up. But what I want to do is for input source, I want to grab something that has a single value like the density. So we'll use the point density as our input source. The output target, we'll put it on a new attribute. We'll call it duplications, for example. And I'm going to keep it set from 0 to 1 here. Our actual duplications will be actually much higher, but we're going to start with this because it makes it easier to use the power node here to force them down. So now we can just use a power node, or in this case, pow. If you type in power, it will come up is just pow. So let's say a power of 3. We can keep it on at last here. And if I press A here and then scroll to the right, you'll see here's the duplications, right? And we're now getting a lot more small numbers. We'll still get a higher one, like 0.938, right? So it does happen, but a lot more of them are small numbers. And of course, we can change this value. For example, if I did 2, you'll get a lot more kind of a medium range, right? It really depends on this value. I'll go with 3 for my setup. Of course, feel free to make all these parameters and expose them so you can control it for your setup. But now that we have this power, I can go ahead and multiply it by how many duplication I actually want. So let's go ahead and multiply this value by 10. At max, I want 10 duplications, so that's what we're going to have. But I don't want them to be floats, so I'm just going to use a ceiling node. So by using ceiling here and then pressing A, again, scroll to the right, you'll see duplications 1, 4, 1, 1, 1, 5, 2. There's a 10 there, but you can see a lot of them are low numbers. 1, 2, there's a 4, there's a few 8s, 2, a lot of 1s. Right, the majority of these are smaller numbers. If I change the power here to, let's say, 2, you will see a little bit more of the kind of the 5 middle numbers come up. There's more 5, 6, right? There's a bunch more here. So it really depends on how much do you want the really tall ones to stand out or not. I like the 3 here. That's what we'll be using. But now they're all actually set up. The duplications are kind of filtered out. So now what we can do is based on how many duplications, let's go ahead and duplicate those upwards. So just like before, I want to actually partition it, but I have currently, in my case, 3 different clusters, and I want to actually partition all of those clusters together. So first, I'm going to go ahead and merge all the points. So that way we have a single piece of data with all of the values here for all 3 of those, or however many we end up having. And now we can go ahead and partition it. So we'll use an attribute partition as we did before. But this time around, we're going to be actually partitioning it by the amount of duplications. So if I pressed A on here, we can see here we have 10 different values. Here's all the 1s. Here's a bunch of 4s. Here's 5. There's some 9s there. They're not in order, but that's okay. It doesn't really matter. There's a bunch of 3s, right? So now we filter them by however many duplications there are. So now let's go ahead and set up the loop that will duplicate them. And the reason we need a loop is because the duplicate node does not like multiple pieces of data. So once again, right click, go to PCG, PCG Graph, empty graph, and I'll call it PCG loop _ duplicate up. And just like before, drag it into the graph, select loop node, and then go ahead and double click to open it up. Just like the other one, this one's set up exactly the same. For the input here, it is a loop point with a required, and the output here is just a point normal. Exact same setup as the other one. So now from this input, we can go ahead and grab them out of duplications by dragging out, get attribute from point index. And the attribute that we want to get is the duplications. So we'll go ahead and put in duplications here. The index does not matter again because we're partitioning by this attribute. So they're always all going to have the same value. And we can now use this on the duplicate point node. We can just use that, open it up, and the amount of iterations will be our attribute here. We're going to plug it in and drag it all the way through. At this point, we can already output this all the way to the output. Nice, simple setup. If we wanted to, we can just go ahead and just drag this all the way through and debug this. And we'll see, there we go. There's all our points. That looks pretty good. So we have a few that are higher and a few that are lower. We'll need to make a small adjustment to this. We'll be able to see that adjustment when we do a static mesh spawner here. Now I can do by attribute, set up a parameter, assign all of the actual rocks that I want to use. But in this case, the rocks are preset. They're always going to use the same rocks. I'm just going to assign them manually and hard code them. But for your setup, again, same way as I did the other ones, you can use an add attribute and assign it. In my case, I'll go ahead and just set up 3 mesh entries here and assign the different rocks. So I have this one, and this last one. Now, a quick note, by the way, when you assign these, if you're expecting collisions, make sure that you actually look up the collision settings because by default, all of them set to no collision. I'm not going to mess with this for the tutorial, but just know that default is no collisions. So make sure that you have things set up the way you want if you're expecting to have collisions with this. But with a static mesh spawner, we can take a look at something. And that is, yes, they are being duplicated up, but the spacing there is a little bit too high. So let's start with fixing the spacing. We kind of want them to be a little more squished together. On the duplicate point node, we can go ahead and modify this by going to point transform. And let's say I want every single point to actually go down 90 units. So we'll put -90 in the location Z, and we take a look, they're a lot more squished down, and we get some weird stuff. Now, why are they now duplicating down, you might be wondering. And I wish I could tell you, and I can't. I looked into this for quite some time, and I cannot for the life of me figure out why a random pillar starts duplicating down, because none of these points are rotated where vertical axis for them relative to itself is down. But for some reason, we now get this. So while these are good, we get issues here. That's okay. That's something we can just filter out. So it's not like we have to keep this. So let's go ahead and filter these out real quick. The easiest solution that I think is just to check that the location of these rocks is always above the location of this actual volume actor. So let's go ahead and just use that. So right before spawning them, after we've duplicated up all the points, let's go ahead and use an attribute filter. So I want to check that the operator here is greater or equal to, and the thing that we're comparing to is the $position.z. I want to compare it to something else, which is the actor's location. So we'll do a right click, get actor data, and we'll use the spatial get actor data. And we'll change the mode here to just get a single point. Where's the location of this actual volume? We can plug that into the filter. And then in these attribute elements, we could specify, okay, I want to compare it to its position.z. And if it is inside the filter, then go ahead and keep those points. And there we go. We now have it working as intended. It doesn't matter where we go up, right? We'll never go down negative here. Again, I have no idea why this is, what is even causing that, but this is just a simple kind of solution here to get it to get fixed. Now let's address the fact that these are all kind of the same going up. Yes, it seems like it's randomizing the rocks. You can see this is a different rock than this, but right, it's very boring. So let's go ahead and after this filter, we can go ahead and add a simple transform points node. And I want to do a few things starting with the rotation. I want to rotate it between 0 and 360. I also want to randomly scale the rocks between 0.75 and 1.25. And you can rotate in the X and Y as well. And I'll show you what happens when you do. And the other thing I want to do is assign our material. We haven't done that yet. So here we'll do an add attribute, again, the parameter one. And here we'll grab the material, drag it out, plug that into the attributes. And now here, I'm going to change the output target here to be material. So that's the name of the attribute. And now on the static mesh spawner, I can have that be plugged in. And then if I look at the detail panel underneath mesh entries, here's the by attribute material override. So we can turn that on and add an entry. And it's going to throw a warning because we haven't plugged anything in. And this is our material. So basically, we're going to override the materials on all the static meshes with this material. So we take a look now. Well, that's a lot more interesting, isn't it? So now we have the pieces actually randomly rotating and stacking. And because it's a world aligned material, right, it goes ahead and transitions really nicely here. Now, you don't have to just rotate along Z here. It depends entirely on the shape of your rocks. If your rocks don't really have a specific flat bottom and top, like some of mine do, they're more the kind of 360 type of rocks. You can change the transform points here to go between 0 and 360 in all 3 axes. This is the result that I get in mine. So while some end up looking okay, the rocks here, they're just, the flat tops don't really work that well. So for my rocks, I'm only going to rotate them along Z. So we get something along this. And now we can go ahead and kind of move these around, right? And we have our setup. We have now our random pillars. Again, if we don't like how many of them are the super tall ones, we can go in here and change the power here, let's say to 5, right? And we get a lot more of the smaller ones, but we still occasionally get the taller ones, right? This one's just really flat, but again, it is all random here. The main thing I wanted to show here is a few things. One, how you can easily duplicate the points upwards, that you don't need to have a super complex setup. This is relatively simple and allows you to get pretty cool results. And if any of you guys do know why it's duplicating the points down in the first place, please let me know. For what I could tell, there should be 0 reason for it to duplicate down when you do the -90 offset. But regardless of that, as always, the project files for this will be available on my Patreon, where you can join these wonderful people in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is in the description below, as always. And if you're interested in learning more PCG stuff, I recommend you this video. I think you might really like.